In 6.1, we're looking at chemical bonding. We're going to look at different types of bonds, why atoms might want to bond, and how those might affect the properties of different molecules and compounds. So first of all, what is a bond? So if we look at this picture, you can see you've got carbon in the middle and you have 4 hydrogens bonded around to that. So basically, if we've got protons that are positive in the nucleus and electrons that are negative, positive and negatives attract. So for this definition, the attraction of the nuclei and the valence electrons. So when it's talking about the nucleus, we're thinking about those positive protons there. So those attractions holding those atoms together. So why would atoms want to bond in the first place? Well, first of all, individual atoms are going to have very high potential energy, and they kind of want to get rid of that. So it's more ideal to have low potential energy. If they bond, that lowers their potential energy. So in nature, they're going to want to minimize that potential energy and become more stable. Here we're going to look at different types of bonds. So first of all, the type of bond is going to depend on how strongly the two atoms are attracted to each other between their electrons. And we looked at that term, which is called electronegativity, in chapter 5. So how badly do those atoms want electrons? So here's a chart, and we've looked at this before, but the blue numbers here show the electronegativities of all the different elements. So if you look at the red one, fluorine, 4 is the highest. We've got some that are in that blue area or that are very low numbers. And so we're going to use this electronegativity chart to determine what type of bond two atoms are going to form. We will look at the differences between the electronegativity numbers. So if we go back to this chart here, let's say we wanted to bond something like oxygen and nitrogen. We're going to find the difference between their electronegativities. So let's look at 3.5 and 3. The difference there is 0.5. And we'll use that number, that difference, to determine what type of bond it would form. Maybe we're going to bond fluorine with lithium. So here we've got 4 and 1. So the difference would be 3. The bigger number minus the smaller. So once we've found that difference, then we're going to use this chart to determine what type of bond would be formed. So if there's a large difference, 1.7 or higher, we're going to form an ionic bond. If the difference is between 1.7 and 0.4, it's going to be considered a polar bond. And if it's 0.3 or lower, it's going to be a nonpolar covalent bond. Now, some charts and some books have a little discrepancy between the 0.3, 0.4, but for our purposes, we're going to use 1.7 to 0.4 will be polar, 0.3 and down will be nonpolar. So the first type of bond we're going to look at, those large differences, are going to be ionic bonds. And so in an ionic bond, electrons are going to completely be transferred from one atom to the other. So if you remember when we talked about the elements want to have a full outer shell, transferring those electrons or sharing those electrons are how we're going to do it. So with ionic bonding, they're going to transfer electrons to the other atom. With covalent bonding, they're going to be sharing those electrons. And so each of the atoms that are bonding get to count the electrons towards their total outer number, typically that 8 that we're trying to get. So if a carbon atom has 4 valence electrons, it could bond with another carbon atom that has 4, And if they're sharing those, then they could each count them as a total of 8. Sometimes they don't share those electrons evenly, and if that's the case, then it forms slight polar charges. So slight negative, slight positive ends to that molecule or compound that's formed. So whichever atom is pulling the electrons more closely towards it is going to have a slight negative charge, and then the other atom will have a slight positive charge. The element that has the higher electronegativity is going to be the one that pulls that electron a little bit more towards it. If the atoms share those equally, there's not that pull, we don't have a positive end and a negative end, then it's considered to be a nonpolar covalent bond. So here we can see chlorine and hydrogen are fighting over those electrons. So polar bonding, they're shared unevenly, and then nonpolar, they're going to be shared evenly. So a polar covalent bond, the electrons are going to be pulled closer to the atom that has a higher electronegativity. So we can see here the difference between two chlorine atoms, each having an electronegativity of 3, the difference would be 0. So it would be a polar bond. They're going to share those electrons evenly. Here, the difference of 0.9, chlorine has a higher electronegativity, so it's going to have that negative end of the pole. Water is a polar molecule. So things that have the same polarity, if something is polar, it's going to dissolve in something that's polar. If something is nonpolar, it can dissolve in something that is nonpolar. A polar molecule and a nonpolar molecule will not mix and they will not dissolve each other. So the polar bear had to be polar if he's going to dissolve in water because water is polar.